Okay, in this question we have to normalize the this wave function which is r to 0 r equal to c naught out of 2a into 1 minus r out of 2a e raised to the power r out of 2a. So to normalize this function we know that we take the integration from 0 to infinity r to 0 into r whole square r square dr. So therefore this can be written as 0 to infinity r square into c naught square, putting the value in this integral 4 a square into 1 minus r out of 2a whole square e minus r out of 2a dr. So therefore this can be written as c naught square out of 4a square 0 to infinity r square into 1 minus r out of a plus r square out of 4a square into e minus r out of 2a dr. So here let u is equal to r out of a, then du out of dr equal to 1 out of a, and dr is equal to u du, and the above integral becomes c naught square out of 4a square from 0 to infinity au square into 1 minus u plus u square out of 4 into a e raised to the power minus 4 minus u, sorry, into uh, u du. So therefore we can write it as, sorry, a du. So this equation can be written as c naught square a cube out of 4a square 0 to infinity u square minus u cube plus u4 out of 4 into e raised to the power minus u du. So this integral can also be written as in 0 to infinity u square e minus u du minus 0 to infinity u cube e minus u du plus 1 out of 4 0 to infinity u4 e raised to the power u du. So integrating this function is very lengthy, a difficult process. So we use a gamma function, which can be written as gamma of z equal to 0 to infinity as u z minus 1 e minus u du. So this gamma function can be written as n minus 1 factorial, and therefore we can write it as c naught square out of 4a into gamma 3 minus gamma 4 gamma 4 plus 1 out of 4 gamma 5. So therefore c naught square out of 4 a 2 factorial minus 3 factorial plus 1 out of 4 5 factorial, and this is equal to c naught square out of 4a 2 minus 6 plus 6. So therefore this becomes c naught square out of 2a, so which is equal to 1. C naught square is equal to uh, 2 out of a, so c naught equal to under root 2 out of a. Therefore we have the function psi 200 r theta and phi equal to r 20 r y 0 to 1 into 0 into theta into L, and we know that this function is equal to 1 out of under root of 4 pi. So we will put here, so the function psi 200 r theta and phi equal to 1 out of under root 4 pi multiplied by under root 2 out of a into 1 minus r out of 2a e raised to the power minus r out of 2a, and this function is can be written as r theta and phi equal to 1 out of under root 2 pi a into 1 out of 2a into 1 minus r out of 2a e raised to power r out of 2a. And in the second part of the question, we consider the case where n is equal to 2 and L is equal to 1, and therefore m is equal to minus 1, 0 and 1. So there are three solutions of time independent Schrodinger wave equation. So we have three waves which are 2 psi 2 1 minus 1 into r theta and phi equal to r 2 1 r y 1 into theta and phi, and the other wave function is 210 r theta phi equal to r 2 1 into r, and this function from 0 to 1 into theta and phi, and phi into 2 1 and minus 1 r theta and phi equal to r 2 1 r, and y from minus 1 1 into theta and phi. Now we will find out the normalization constant C naught, and therefore we have a formula that is minus plus 1 to 1 into theta and phi equal to a plus minus 3 out of 8 pi in under root sine theta e raised to the power plus minus iota phi, and therefore y 0 to 1 theta and phi equal to 3 out of 4 pi cos theta. So now we are going to normalize the function as we have a function which is 1 equal to minus infinity to infinity r square into r to 1 r square dr. So therefore this can be written as c naught square out of 16 a4 into minus infinity to infinity r for e raised to the power minus r out of a dr. So here let r out of a is equal to y, sorry, is equal to u. We take it as a u, then u du is equal to dr. So we put in the integral, we get c naught square out of 16a4 minus infinity to infinity au4 into u du. So therefore this integral is c naught square 16 a4 into a5 integral minus infinity to infinity u4 e raised to the power minus 4 du. So therefore c naught square a out of 16, and this integral is from 0 to infinity. So this is from 0 to infinity, and u4 e raised to the power minus 4 du. Again use the gamma function, as gamma function is gamma n is equal to n minus 1 factorial. So therefore c naught square out of 16a 4 factorial. So this become c naught square out of 16 into 24. So we can write it as 1 is equal to 3 out of 2 a c naught square. So therefore c naught equal to 2 out of 3a, and c naught equal to under root 2 out of 3a. So we have c naught. So now we will find out these three expression. So we have the expression, so psi 2 1 plus minus 1 equal into theta r and phi equal to r 2 1 r y plus minus 1 1 into theta and phi. So putting the value we get as under 2 out of 3a multiply by 1 out of 4a square um, multiply by e raised to the power minus r out of 2a into plus minus under 3 out of 8 pi and sine theta e raised to the power minus plus minus iota phi. So these term will get cancelled and we get the value as uh, minus plus 1 upon under root pi by a into 1 out of 8 a square or e raised to the power minus r out of 2a sine theta e plus minus iota phi, and the other function is psi 210 theta r and phi equal to r2 1r and y01 theta phi. So we can write it as, by putting the value we get on root 2 out of 3a multiply by 1 out of 4a square r e raised to the power minus r by 2a multiply by under root 3 out of 4 pi cos theta. So again we get the value as, so the value we get is equal to 1 out of under root 2 pi a multiply by 1 out of 4a square 4a square r e minus r by 2a cos theta.